Children, let's take a very good sum which involves OR in the event, right? Let's see, directly check the question, what the question has to say. Indeed, a very good sum, children. One lottery ticket is drawn at random from a bag containing 20 tickets, numbered from 1 to 20, 1, 2, 3, 4, up to 20. Find the probability that the number on the ticket drawn is either even number or square of integer. Either it's an even number or square of integer. Second thing, divisible by 3 or 5. Let's start to understand how we need to solve sum which involves OR in the question. Solution. So what could be the sample space? We have to write down the sample space for lottery tickets is given by S is equals to 1 What shall be my n of s, children? What shall be my n of s? My n of s will be 20. My n of s is 20. Let's begin with our first answer. They say the first event says either it has to be an even number or square of the integer. We have to take both the events within the first question separately. Let A be the event of getting even number. So when I say even number, what could be the sample points in event A? 2, 10, 12, 14, 16, 18, 20. What is n of A? N of A is, children, 10. There are 20. Altogether, even will be 10. What is the probability of this event? P of A is going to be n of A upon n of S. 10 by 20, eventually 1 by 2. 10 by 20, eventually 1 by 2. Let me show you simultaneously, or let me jot down besides this so you can understand. Let B be the event. B be the event of getting square of integer. Square of integer. So what could be the sample points? B is equals to, within this 1 to 20, which are the numbers which are squares of integer? Can I say 1, 4? Yes. Go ahead. 1, 4, 9, 16. 1, 4, 9 and 16. Square of 1, square of 2, square of 3 and square of 4. What is n of B? N of B is 4. What is probability of B? Probability of B is n of B upon n of S, which is 4 by 20. 4 by 20, answer is 1 by 5. Children, whenever we have or, I have told you earlier in my slides, we are supposed to go for union, means we have to take from both. Keeping one thing in mind, there shouldn't be any sample point which are common to both. If there are some sample points which are common to both, then we have to take the intersection part and subtract that. I'll show you what exactly I wanted to say that. I'll just show you via the solution. This is what the probability of A is. This is what the probability of B is. Let's check whether we have any kind of sample points in common. Sir, 4. Sir, 16. Anything else? Any sample points being common? No. So these are the two sample points which are common, means intersection, right? Intersection. Now, what is n of A intersection B? N of A intersection B is, there are two, or rather first you say, what is A intersection B? A intersection B, there are two sample points. One is 4, as I have highlighted over here. Another is 16. So 4, 16. 4 and 16. What is n of A intersection B? N of A intersection B is 2. Probability of A intersection B is n of A intersection B upon n of S. 2 by 20. 2 by 20. Answer is 1 by 10. As we have n of S as 20, 2 by 20, answer is 1 by 10. We are not done here, children. We are not done here. There is an addition theorem for probability. What is addition theorem for probability says? Addition theorem for probability says, or means union. So by addition theorem of probability, P of A union B is P of A plus P of B minus P of A intersection B plus P of A intersection B. If I say P of A, what was my answer? P of A, 1 by 2. What is P of B? P of B is 1 by 5 minus P of A intersection B, 1 by 10. Children, LCM is what we are going to go for. Into 2, into 2, into 5, into 5. Why? Because LCM turns out to be 10. So what answer will I get? 5 plus 2 minus 1 by 10. Final answer, probability of A union B is 5 plus 2, 7 minus 1, 6 by 10. Eventually 3 by 5. Eventually 3 by 5. This is what my answer is when I say that the event either is even or square of the integer. Mind you, event was either the number is an even number or square of the integer. What thing we are supposed to take into account? Once again, I shall refresh it. We always find out the first part of the event, even. Probability of that. We take the or part. Probability of that. We take the intersection part. Probability of that if there is an intersection. And then by the addition theorem of probability, P of A union is P of A intersection B. Likewise, children, likewise, on the same lines, if I have to do the second question, how am I going to solve it? I want you to go and understand this, make a replica solution. I am writing the solution very short. I'm writing this second part very short. I want you to write down with all the statements. So if I take this particular sum, what can I say? Let C be the event of getting what? Of getting a number which is divisible by 3. Of getting number which is divisible by 3. So how many numbers do I have in that? C is 3, 6, 9, 12, 15, 18. 3, 6, 9, 12, 15, 18. N of C is 1, 2, 3, 4, 5, 6. P of C, N of C, N of S, 6 by 20. 3 by 10. Let D be the event of getting divisible by 5. Of getting divisible by 5. A number divisible by 5, mind you. What is the sample points in event D? 5, 10, 15, 20. 5, 10, 15, 20. What is N of D then? N of D is 4. Probability N of D, mind you, this is N of D is 4. Probability of D, N of D upon n of s. 4 by 20, which is 1 by 5. Now, are there any common sample points to both? Sir, I see only one, which is 15. Do you find some other? No. Then what can I say? N of, or first, C intersection D. Now, how much is C intersection D, or what are the sample points? Only one, which is 5. N of C intersection D is 1. What is the probability? N of C intersection D is 1. N of C intersection D is 1. Then, what is the probability? What is the probability of C intersection D is, probability of C intersection D is N of C intersection D upon N of S. N of C intersection D upon N of S. What is it? N of C intersection D and N of S. Answer is 1 by 20. Answer is 1 by 20. So, when I say 1 by 20, what is addition theorem trying to say? What is the addition theorem of probability trying to say? Probability addition theorem says that probability of C union D, probability of C union D is, probability of C union D is probability of C plus probability of D minus probability of C intersection D. Answer is, first we had 3 by 10, thereafter we had 1 by 5, and finally we have we have 1 by 20. Finally we have 1 by 20. Then what's the answer? Into 2 into 4. Answer is 6 plus 4. 6 plus 4. I think so. We had, instead of, I've written here 5, it should be 15. It is not 5, it is 15. Correction, it's 15, not 5. Answer is the same. 6 plus 4 minus 1 by 20. 10 minus 1, 9 by 20. So what is the probability? The probability is 9 by 20. The LCM turns out to be 20 into 2, 6 into 4. So 4 minus 1, 10 minus 1, 9 by 20. This is how we deal with, sums which are based on or sums which involves or as a intermediate, or you can say sums which have two conditions involving or in between them. Children, this is a totally different kind of sum, right? Just go through it once more. If you have any kind of doubt, refresh it once more and the picture will be more clear.